Today we are going to see convolution codes, how to get your state table, state diagram, trellis diagram and code tree. This is vanilla. The convolution coding is done by combining the fixed number of input bits. So here the input bits are stored in a fixed length shift register and they are combined with the modulo 2 adders. So since it involves both the shifting as well as addition, it is equivalent to your binary convolution. So we are saying it's a convolution encoding. So we can have an example here. So here this is a shift register where you are going to have a message bit as an input. So here you have only one message and then this M1, M2 and all shifting that one single bit. So now the shifting process can be done in the shift register. We'll see the modulo 2 adders also. So here I am going to take this modulo addition of M, M1, M2 and let it be your X1. So this is going to be the output X1. Then I will have one more output. So modulo combination of this M2 and then this M. So that let it be your X2 here. So here in your linear block code, n comma k, n will give you the length of the block, k will give you the message bit. But here this n comma k will give you the n comma k will give you the n is your number of outputs. So how many outputs you have? So that will be your n. So here for this convolution codes we have two outputs. So your n is equal to 2 and k is going to be your input. So how many bit you are going to have the input? So here only one bit as an input. So here this convolution can be called as 2 comma 1. So here the current state, right? So here the current state is your M2, M1 is a current state. Your M is going to be your input. So M2, comma M1 is going to be the current state. So your output, here you have two outputs X1 and X2, where X1 is equal to M modulo M1 modulo M2. And X2 is going to be the second output. So where X2 is M modulo M2. Then what will be your next state? So your current state, here you have M is your input. So this is going to be your input and then your M1 and M2 is going to be the current state. So if you are going to perform a shifting operation, first what happens? Your M2 will go out. Your M2 will go out. So making the space for M1. So this M1 comes to this place. So M1 moves to this place. Next what happens? The M will move from this place to this place. So your M will move from this place to this place. So your previous state, that your current state is M2 comma M1. Now your current state, next state will be your M1 comma M. So that will be the next stage. So this is going to be before shifting and this is going to be after shifting. So before shifting is going to be your current state, after shifting is going to be your next state. So now we solve the problem how to draw the state table, Trellis diagram, state diagram for and the code tree for the convolution code. We can see this one. Now we saw the output x1 and x2 and this is going to be your 2 comma 1 coda. So 2 is going to be the number of outputs and 1 is going to be the message bit. So here this is going to be the state table. So since you have two current state, that is your current state is M2, M1. So you have 2 bits, the number of possible combinations is going to be 4 and your input is M. Your next state will be, your output is M, X1, X2. Your next state will be M1, M. So your current state is going to be your two current state here. So here you have 4 current state, that is your 0, 0, 0, 1, 1, 0, 1, 1. So let the state be named as A, B, C and D here. Okay, so now we are going to see what is your output when your input is going to be 0, when your input is going to be 1. So now with the help of the equations we can calculate. So here your equation, if your input is going to be 0. So if my input is 0, what is my output? So using this equation, m modulo 2 m1, m2, we will find the equation here. So since all this value is 0, your output x1 and x2 are 0 here. If your next state is going to be m1, m is the next state, so 0, 0 is going to be the next state. Now we'll see if your input is 1, your x2 is going to be your m2 plus m1 plus m is going to be your 1, and your x2 is going to be m2 plus m is going to be your 1. So what's your next state? Your m1 and m is the next state, so 0, 0 and 1. So similarly, I'll find for 0, 1. So if your input is 0, so what happens here? 0 plus 1 plus 0 is going to be 1, and 0 plus 0 is going to be 0. Your next state is going to be 1, 0. So if your input is 1, so 0 plus 1 plus 1 is going to be 0. It's a modulo 2 addition. So 0 plus 1 is going to be 1. And your next state is going to be your m1 m, that is 1 1. Similarly for 1 0, if your input is 0, it's going to be 1. If your input is, x1 is 1 and x2 is going to be 1. Your next state is 0 0. And if your input is 1, so 1 plus 0 plus 1 is going to be 0, and 1 plus 1 is going to be 0. Your next state is 0 1. For your input 1 1, sorry, for your current state 1 1, your input 0 means 1 plus 0 is going to be 0. Then your m2 plus m1 plus 0 is going to be 1. Your next state is 1 0. If your input is 1, your 1 plus 1 plus 1 is going to be 1, and 1 plus 1 is going to be 0. Your next state is going to be 1. Now we have your next state in terms of your A, B, C, D. So 0 0 and all, it's A, 0 1 is B, 1 0 is C, and 1 1 is going to be your D. So with this state table, we are going to get your trellis diagram, state diagram, and code tree. So we'll get your trellis diagram first. So I have the state table side by side so that I can draw it comfortably. So here in trellis diagram, I'll take your current state. Current state I have four states: A, B, C, and D. So I'll just draw the four states A, B, C, and D. And I'll take your next state. So next state is also going to be A, B, C, D. So I'll take the same four state A, B, C, D. Now from your current state A, here one rule is here is there. If your input is 0, I'll be using your straight line, solid line. Suppose if your input is 1, I'll be using your dash line. So this is going to be the rule. Okay. So if my input is 0, from your state A, it goes to the state A. At that time your output is 0 0. So from your state A, it goes to state A. I use your solid line. And what is your output here? Your output is going to be 0 0. Your output is 0 0. Now from your A, it goes to B if your input is going to be 1. So I'll be using your dash line. So from your A, it goes to B, and then your what is your output? It's going to be 1 1. Right. So from your B, it goes to C. Your output is 1 0. So from B to C, output is 1 0. It's a solid line because your input is 0. Similarly, I'll take your for input 1. It goes from B to D. So your output is 0 1. Similarly, when your input is 0, your C goes to A, and then what is your output? It's going to be 1 1. Then from your C it goes to B if your input is going to be 1. Your output is 0 0. And from D it goes to C if your input is 0, your output is 0 1. And for 1 it goes to D. So with your output is going to be 1 0. So this is about your trellis diagram here. I hope you have understood this trellis diagram. Now we'll see the state diagram. It's saying that of the trellis diagram here, I'll take the four states here A, B, C, D. So however you're going to place your states, your diagram gets different. But the concept is going to be same. So here also I'll be using solid line for input 0 and dash line for input 1. So here from input to 0, from A it goes to A. So from A it goes to A. and then at that time your output is going to be 0 0. And from A it goes to B. If your input is 1, where your output is going to be 1 1. Then from B, if your input is 0, it goes to C. If your input is 1, it goes to D. So from B, it goes to C. And then from B, it goes to D if your input is going to be 1 and then your output is 0 1. And from C, if your input is 0, it goes to A. If your input is 1, it goes to B. So it's going to be your C to A, your output is going to be 1 1 and then C to B. So C to B, your output is going to be 0 0. Then from D, if your input is 0, it goes to C. It goes to C. At that time, your output is going to be 0 1 and from if your input is 1, it goes to, it remains in your state D with your value 1 0. So this is your state diagram. So next we will see the convolution code. So convolution codes in the one code tree we are going to see. So code tree is you have two rules. If your input is 0, it has to go upwards. So I'll take the same state table. If your input is going to be 0, you are going to take it in the upward direction. And if your input is 1, you are going to take it in the downward direction. So I'll start with this one and then I'll move to the tree. Once I'll get all this as an answer. So I'll take the state A and then if your input is 0, it goes to A and then what happens? Your output is 0 0. So it goes to A, then your output is 0 0. If your input is B1, it goes to the downward direction, it goes to B. So it goes to B with your input as 1 1. Again from A, if your input is 0, it goes to A, 0 0 is your output and if your input is 1, it goes to B, your 1 1 is going to be the output. And from B, it goes to C when input is 0, it goes to D when input is 1. So at that time, your output, corresponding output has been noted. So from each and every point, all the 4 points has to be obtained here, right? So from this A, I got AB. From this B, I got B, C, D. So similarly, I'll go for from A, I'll go up. If it is input is 0, it goes to upward direction, that is A, and then B if your input is 1. And similarly from C, from B, it goes to C. When your input is 0, the output is going to be 1 0, and it goes to your state D if your input is 1 and the corresponding output is going to be 0 1. And from C, if your input is 0, it goes to A with your output 1 1 and it goes to B if your output is going to be 0 0. Similarly, from D, if your input is 0, it goes to C with your output is 0 1 and it goes to D if your input is going to be 1 and output is 1 0. So now I got all A, B, C, D, A, B, C, D. So A, B, C, D, A, B, C, D. So this is how your code tree should be drawn. So I'll give an example here. Practice for a problem for a practice here. A RAID 1 by 3 convolutional encoder has generating a vector G1, G2, G3. So here they ask you to search the encoder configuration and draw the Trellis diagram, state diagram and code tree. So here I'll help you to get your encoder diagram. So here they have given 3 values here. So default is going to be M, M1 and M2. M, M1 and M2 here. So here this is going to be your single bit where 2 bits is going to be shift. So this is going to be M, M1 and M2. So how many output you have? G1 is going to be one output, G2 is going to be another output, G3 is going to be another output. So we can say this as a 3, 1. And your rate is given by K by N is your rate. So rate is given by the formula K divided by N. That's why 1 by 3 is your rate. 1 by 3 convolution encoder. From that one, I can say I have 3 output, 1 input. That's why 3, 1. So here this G1 can be written as M. G1 is M and G2 is going to be your M and modulo M1 modulo addition M2 because all are 1. And your G3 I can write this as M modulo M2. So your M1 is going to be 0. So with this equation I hope you can draw the state table first. From the state table you can get your Trellis diagram, state diagram and code diagram. Have a nice day. Subscribe my channel for automatic.